On today's video, we'll be working on a no AC coil. See, the first thing you want to do is you want to come here where your thermostat is located and you want to set it to cool. Make sure it's on auto. This is the temperature inside and the ambient temperature around the thermostat, and we want to lower it. You can see here it's already set to 74 degrees cool. There is a delay sometimes, so you see here where it says cool, it's going to remain like that. Once the signal is sent, it'll give a small click and it'll start flashing. There are different thermostats that function in different ways, but you do want to wait for that delay for it to send the signal for cool to start. Here, if you look where my finger is, right below my finger, you'll see that it is saying cool, and that does tell me at this point that I should have my system up and running. Right now I'm just checking the temperature and we are at 90 degrees. I'm here at the evap coil, and here's where my blower and my controls are located. You can see right now that I do have my system plugged in. Well, right now I do not hear my blower motor running. Right now I'm just going to check the breakers, make sure that there's nothing tripped. So we are able at this point to eliminate the issue of a trip breaker. Right now I'm just checking for voltage coming in. So I do have 120 volts coming out of my outlet. Here I'm checking the top as well, so I do have the proper voltage. If you don't have an outlet, it's possible that you may have a switch that is feeding the power. If you have a system like this, or even sometime in the attic in the FAU, you may have a switch like this, and basically instead of the outlet plugging in and out, you would flip it off, and that would kill the 120 volts to your system, and that would turn it back on. Just for demonstration purposes, we'll turn the fan to the on position. You can see here the fan is running. And what I'm going to do is I'm going to turn the switch off, and that will remove power. Plug it back in. Here we are. This is going to be the condenser that feeds to my unit, and I can see that my condenser is running, so I am getting the low voltage going to my contactor. So at least at this point we isolate the problem to here at the evaporative coil, specifically the blower motor. We're just going to remove our panel. So here we should have a door switch, but you can see that for whatever purposes this was cut out and removed. I do not recommend doing this. This is your safety when you're working on the system, and if you bypass it, you're allowing or endangering yourself from getting shocked. So I do not recommend you cutting out your door switch, your safety switch, and tying the lines together. If the door switch was operational and functioning properly, when you remove this panel here at the bottom, your switch will disengage, and that will kill power to the evap and the blower. You can see here, this is a door switch that we have. I have on this one the thermostat set to on blower. And what I'm going to do is I remove this panel. I have the 120 volts here. And what the door switch does is it allows you to remove power while you're servicing the panel for safety reasons. You can see here I'm going to engage it, the fan is on. So when you eliminate that switch, what you're doing is you're removing the safety mechanism to protect you from allowing you to work safely. Again, if that door switch is cut out as it was in the other one that I've been working on, you will have to go ahead and somehow remove the power. If for some reason you can't find it, you may want to go ahead and flip the breaker. For safety purposes, we are going to remove the 120 volts feeding to our system. Once you ensure that the power is removed, what I like to do is I like to inspect the blower motor. And a lot of times what happens is if you come here, you want to see if you can manually rotate the shaft, the squirrel cage, And you can see here that it is rotating. A lot of times when the motor goes bad, it'll cease up. Next, you'll also want to tap the motor to see if it's hot. And right now, this motor is not hot. Now that indicates to me that the blower motor has not been running. If I come here and I feel the blower motor is hot, then I know at this point that it is running. But at this point, in just kind of regular basic observation, I can tell that my motor is not ceasing up, it's rotating freely, and my motor is not hot. The next thing we'll look at here is the capacitor. Now with the capacitor, you have two lines feeding it, and I can see here, it's probably been sitting here for quite some time. You can just see all the dust that's on there. So right now, we're going to go ahead and replace the capacitor. What I'm going to do is I'm going to plug in my 120 volts, and what I'm doing is I'm going to basically just come down here and just check the blower motor to see if it's running. And you can see here, I hear it humming like it's trying to run, but you can see it is not turning. Here I'm going to remove the power. Now before you work on the capacitor, you do want to discharge it. It's pretty basic and simple. Here we have a screwdriver, and what you're going to do is you're just going to tap the leads and just allow them to touch. And once you do that, that will discharge your capacitor. Again, safety is very important, so make sure you do follow this step. Here we just removed our two leads feeding to the capacitor. This is our new capacitor. You just want to make sure when you replace the capacitor that you put the proper MFD rating. You can see here this is a 7.5 MFD. You want to ensure that you put the proper one as not to damage the blower motor. I have seen or gone to situations where I received a call and it was a 7.5 MFD capacitor on the blower motor, and somebody came and put a 5, and what happens over time is the blower motor ends up going bad. Here I connected my two leads going to my new capacitor. What I want to do is I want to tie this capacitor down. You can see it moves freely. I don't typically like that because what happens is over time as the blower turns on and off, this will cause the capacitor to fall out. Right now we're just resecuring it, making sure it's nice and tight. Also, you may have a little rubber guard that goes over the capacitor. If you do have that, go ahead and put it back on. It may look something like this, and basically this is just to kind of protect your capacitor and from just allowing any short or anything from happening. So sometimes you'll find it, and if you have it, go ahead and put that back on. This one does not have the rubber guard. You just want to make sure that you don't have any of the leads touching the side of the blower. Now that we've replaced the capacitor, we're going to supply our 120 volts. So here you can see the blower motor is running. What we're going to do right now is we're going to take the temperature at our vent, and we're going to kind of see if we let the system cool down. So here I have my multimeter set up. I have my temp probe going up into the vent, and we are reading 57 degrees. So here it's been a few hours. You can see we already dropped to 83 degrees. One thing I do want to mention, oftentimes that escapes, especially technicians who are new to the industry, you always want to take into consideration the ambient temperature outside. If it's 100 degrees outside and the AC hasn't been running or the power's been off in the unit, it is going to take a few hours, sometimes anywhere from 12 to 24 hours, for the system to actually cool down to the set temperature that you have it to. So always keep that in mind when you're speaking to your prospects. Let them know, especially if it's a 99, 95, if it's over 100 outside and their AC hasn't been running for a few hours, it is going to take time to cool off properly because the ductwork at that point has been heated up. Especially if the ductwork is in the attic, it's even hotter up there. You have to consider the walls that are facing the sun. All these do affect how much time it's going to take for your system to properly cool. This video was a help. If it was informational, please subscribe.